Good morning, guys. So what we're going to start working with today, we're going to start working with something different in the new unit. So we're going to be analyzing different types of angles this week. We're going to be working on interior angles for all different types of geometric figures, different types of polygons, and we're also going to be working with the exterior angles of different types of polygons and their measures. How their measures can be determined, how their measures can be applied to determine unknown angles, right? So today we're going to start with something easier, just because again it's our first day back from break, but it's also our first day back for teachers back at Eastside. And since they told us it was an asynchronous day, I figured we might as well give you the easier of the two topics to focus on first. So what we're going to be focusing on today is something that's called exterior angles, right? We've touched already before on exterior angles, but not in these regards, right? So exterior angles, again, it's whenever you're dealing with any figure, exterior angles are angles that are always on the outside of a figure, right? Interior, which we're going to work on Thursday, are going to be the angles that are inside a figure. And when we work with exterior angles, we worked in relation to triangles. What we're going to be working with today are the exterior angles for any type of geometric figure, right? Any type of polygon. And the good thing about exterior angles, right? So I'm going to start with a figure that looks like this, right? So in this case, we're not working with the triangle. We are working with a quadrilateral, right? All the quadrilateral is, it's just a figure that has four sides. Any figure that has four sides is a quadrilateral. And so we have four exterior angles. And the thing that we know about the exterior angles of a polygon is whenever we're dealing with any type of exterior angles, it doesn't matter whether it has 4 sides, whether it has 10 sides, whether it has 20 sides. If we're dealing with exterior angles will always add up to 360 degrees, always. Exterior angles will always add up to 360. Will always add up to 360 degrees, always. It doesn't matter how big the figure is, it doesn't matter how many sides it has. If it's exterior angles, it's always going to add up to 360. So it's that whole idea of, let's say that this is 100 degrees, right? This then is going to be, let's say that that's going to be 120. This here will make it 80. This here, we can make it 60, right? And again, the whole idea, whenever we add up these four angles, they're always going to add up to 360. And the reason why all exterior angles add up to 360 degrees is because whenever we're taking all the exterior angles and bringing them together, as you're actually taking them and bringing them all together, it starts making a circle, right? And when we join them all together, it makes a perfect circle. What we know about a circle is a circle always adds up to 360 degrees. That's why exterior angles will always add up to 360, because when we join all the exterior angles, it makes a circle. Circle adds up to 360, so exterior angles will always add up to 360. Again, does it matter if it's exterior? 360. Now, we're actually going to use it to see how we can apply it, right? Because the idea of applying exterior angles, it's not difficult whatsoever to try to determine the measures of unknown angles, right? So we'll start then with one that's what we were seeing, right? We'll start with the quadrilateral. And again, in this case, draw a quadrilateral that looks like this, right? Sometimes it's just easier to draw it this way with the figure first and then just extend it, right? And so I'm going to put measures here. Again, we're dealing with exterior angles. I'm going to make this one here. I'm going to make this M, right? I'm going to make this angle here. Let's make this 110 degrees. And then again, just going by measures. The measures are not accurate to the figure, guys, just because I don't want to spend that much time trying to make it look perfect as well. So we have M, we have 110, we have 65, we have 47, right? And what we want to do is we want to determine the measure of angle M, right? So what we know, when we have all four of these angles are exterior. So when we add them up, we know that all these exterior angles are going to add up to 360. So it's that idea, right? If we add up all the exterior angles, it will always add up to 360. So we can write that. We can write that m plus 110 degrees plus 47 degrees plus 65 equals 360, right? And I'm going to write it bigger just for you guys to be able to see it better. M plus 110 plus 47 plus 65 equals 360 degrees, right? Always. And this whole idea, it's just that. It's us adding up all the exterior angles and setting it equal to 360. And it's always going to be equal to 360 because if we're working with exterior angles will always add up to 360. And now once we have that, it's just combining like terms, right? So we can combine the 110, we can combine the 47, we can combine the 65. When we add up 110, 47, and 65, it's going to give us 222, right? So m plus 222 degrees equals 360. All we did was just combine those three like terms because they're all together here, and it gave us 222. Now we just want to solve for m. So in order to get rid of 222, do the opposite of addition, which is subtraction. Subtract 222, subtract 222 from the other sides. Those two cancel, so we're left with m equals 138 degrees. There's our answer. We know that m is equal to 138. We know that this would be 138 degrees because, again, if we were to add up all four of these angles, they would now add up to 360. 360 makes a circle. Exterior angles form a circle when we join them all together. That's how we know our answer is right. And it's just that idea. Whenever it's exterior angles, we always set it equal to 360 degrees, guys. Here, let's try two more when it comes to these. So I'm going to draw this down again. And I'm doing this on purpose because I want you guys to be careful, because sometimes people have this thought that whenever they see a triangle, it doesn't matter. It's always got to be 360 degrees. It's always got to be 180 because people are ingrained to just think triangle, 180. And it's not. Whenever we're dealing with the interior angles of a triangle, it's 180. When we're dealing with the exterior, it's different. It's 360, right? So I'm going to make this 5F. I'm going to make this 4F. And I'm going to make this 3F. And all I want you to do, I want you to just solve for F. And again, people may think that it's complicated, but it's not. All it is, we're just going to combine all of it, add them all up, and set it equal to 360, right? So it would be 5F plus 3F plus 4F equals 360. And again, it's 360 because when we're dealing with exterior angles are always equal to 360, always. So 5F and 3F is 8F. 8F plus 4F is 12F. So all I did, guys, I just combined those three like terms. 5 plus 3 plus 4 gave us 12F, right? Equals 360. Now we want to solve for F, right? So we got to get rid of the 12. The inverse of multiplication when they're together. Opposite of multiplication is division. So divide this by 12, divide this by 12. 12's cancel out, and we're left with F equals 30 degrees. Because all I did was 360 divided by 12 gives us 30. So all we know, F is equal to 30, right? That's it. It's just that idea, guys. And then if we wanted to actually determine the measure of each angle, we could just by substituting. We do 5 times 30, 4 times 30, 3 times 30, give us all our angle measures, right? One more. And again, it's going to look more complicated just because it's a figure that has more polygons, but it doesn't matter, guys. It doesn't matter how many sides. If it's exterior, it always adds up to 360, guys. So I'm going to try to draw this as easy as possible for me. So let's do that. Let's do that. Draw this here. We'll draw this here. And then we'll draw this like that, right? And so I'm going to add in the measurements now. So I'm going to make this 5x. Where is it? Let's make this 5x. Let's make this one here 3x. Let's make this 110. Let's make this 110. Let's make this one 2x, and let's make this one 50, right? So we have 2x, 3x, 5x, 110, 50 degrees, right? And again, we just want to solve for x. We want to solve for x. Again, we have a 5-sided figure, right? So a 5-sided figure, we're going to learn pentagon, right? And again, whenever we're dealing with exterior angles, add them all up, set them equal to 360. So it's going to end up being 5x plus 2x plus 3x plus 50 plus 110 equals 360, right? We're just adding them all up, setting it equal to 360, right? And so once we have that, again, let me just write this bigger, guys. We're going to have 5x plus 2x plus 3x plus 50 plus 110 equals 360, right? We're going to add up all 5 of those terms. Again, just wanted to make it easier for you guys to see it. And now all we're going to do is combine like terms, right? All the x's, so 5x, 2x, 3x. So 5 plus 2 is 7, 7 plus 3 is 10x, right? So we're done with those, we combine those 3. Now we want to add the 110 and the 50. 110 plus 50 gives us 160, right? Equals 360. So all I did was just combine my terms. 5x, 2x, and 3x is 10x. 50 and 110 is 160. Now, in order to solve for x, first let's get rid of that 160. Opposite of addition is subtraction. Subtract 160 from both sides. Gives us 10x equals 360 minus 160 is 200. Now, opposite of multiplication, division. Divide this by 10, divide this by 10. 10's cancel out. We're left with x equals 20 degrees. And again, guys, it looks more complicated, same idea. Just always remember, whenever we're dealing with exterior angles will always add up to 360 degrees. If you have any questions, guys, always feel free to ask. And again, enjoy the rest of your week, guys. Take care.